So we're doing our example part. So we are focusing on growth and decay. So in the last video, or the content video, I explained how to solve a differential equation, and I showed how this differential equation leads to this solution curve, or this solution equation. And this is the growth and decay model. If the K value here is positive, you have growth. If this K constant is negative, you have decay. The C value here is always your Y sub 0. It's your starting amount, 0, C. So the starting population when time, this is an ordered pair, that is T comma Y. So T is our independent variable and the Y is the dependent variable. So T is your first coordinate and Y is your second coordinate. So at time 0, the starting population is the constant C. So we're going to use that information and to help solve some growth and decay problems. All right, so let's just start kind of general for you to get the idea of what's going on here. It says the rate of change of Y is proportional to Y. So that means the rate of change of Y is proportional to Y. So I'm starting off with this equation. I don't have to do the algebra anymore. I know this equation automatically leads to this, CE to the KT. I know it automatically leads to that equation because we've done the math. All right, so now we're just ready to roll. It says when T equals 0, Y is 2. Well, that is my C value, because that's the ordered pair 0, 2. So when time is 0, C is 2. Now, if you need to, you could plug it in. So Y is 2. Y is 2 when T is 0. So doing the math, this is going to be e to the 0, which is 1, so C is 2. But we know we don't have to do that math. We know that anytime you have T equals 0, then whatever this value is, that is your C variable, the coefficient there. So I know C is 2. So now in my equation, I now have this much, 2e to the kt, because the C value, the coefficient C, is the value 2. Okay? So now I'm going to use this next little part. When T equals 2, I get Y is 4. So now I'm just going to sub in again. So Y is 4 when T is 2. So now I'm going to solve for the K. So I'm going to divide by 2 on both sides. And now I'm trying to solve for this K variable that's in the exponent. So the only way to get it out of the exponent is to take the natural log. The reason you do that is when you have natural logs, you can move the exponent to the front. All right. So now that I've done that, the natural log of E, that's 1. So this is just 2K times 1, because this equals 1. So that's going to be 2K equals the natural log of 2. And then I'm going to divide by 2 on both sides. And I'm not doing the natural log of 2 divided by 2. So that's not going to be the natural log of 1. That's the natural log of 2 quantity divided by 2. So K is the natural log of 2, the whole quantity divided by 2. So now I can go back up here to this equation. 2 equals, the K is natural log of 2 divided by 2. So natural log of 2 divided by 2 times T. So now that's my equation. So now it says, the third part of the thing says, what is the value of Y when T is 3? So now I'm just going to plug a 3 in here. Y equals 2e to the natural log of 2 divided by 2 when T is 3 times by 3. And now I'm just going to use my calculator because I can't do that in my head. So 2 multiplied by E raised to the 3 ln, let's see, 3 ln of 2 divided by 2. That's what I got, 3 ln of 2 divided by 2. And then press enter. And I get 5.657 rounded to 3 decimal places. So when T is 0, we had 2. When T was 2, we had 4. So when T is 3, it should be somewhere, let's see, find the value of Y When t is 3, yeah, so when t is 0, we had 2. When t was 2, we had 4. So we're slightly growing here. So when t is 3, I should have more than 4. I've got 5.657. So that makes sense. All right. So that's how we solve those using E and LN. So this is just going to be a little bit of practice with this. All right, so here's an actual word problem dealing with the same situation, same type of problems here. It says, suppose 10 grams of plutonium isotope, and this is just the name of it, Pu-239, was released in the Chernobyl nuclear accident. How long will it take for 10 grams to decay to 1 gram? All right. And then it tells you, this is, again, just its name. This plutonium isotope has a half-life of 24,360 years. All right. So we've got this equation, y equals CE to the KT. All right. So using the information that they gave me here, I know that at times 0, I have 10 grams. So that would be the ordered pair 0, 10. Okay. I already know that that's my C value. So y equals 10 e to the KT. All right. The next thing I know here, it says we have a half-life of 24,360 years. So what does that tell me? That tells me in 24,360 years, I'm now going to have only 5 because the half-life is 24,360 years. So in that many years, I will have half as much. I will only have 5. So let's go ahead and use that in our equation, and that'll help us find K. So I will have 5 when the time is 24,360. Okay? So now I'm solving this. Now notice when I divide by 10, I get 1/2. Okay? And that's always going to be true. So if something has a half-life, then its e to the KT is going to equal 1/2. Okay? If something has a half-life. So now in order to solve this, we're going to take the ln on both sides. The ln of 1/2, ln of e to the K 4,360. The reason you do the ln, again, is because you can move this coefficient to the front. And you can put this in a calculator if you want to. I usually don't. I usually wait to the end. We know ln of e is 1, so that goes to 1. So we just end up with this amount. So in order to find K, we're going to divide by 24,360. So K is going to equal some really small number. All right, so it's the natural log of 0.5 divided by 24,360. Okay, and it's given it to me in scientific mode. For some reason, I couldn't think of what it was called. Scientific notation. So it says it's negative 2.845 times 10 to the negative 5. I'll write that down first. So negative 2.845. That'll be good. Times 10 to the negative 5. All right. So what does that look like? To the negative 5 means I need to move my decimal point over. So that's going to be 0.0002845 because I moved my decimal point over 5 to the left. So 1, 2, 3, 4, 5 to the left. So there's really the decimal I'm looking at. All right. All right. So now my equation at this point now, going back up here, this was my original equation before. So now I can put in my K value. So y equals 10 e to the negative 0.0002845 t. I think I copied it correctly. Let's see. 4 zeros and then 2845. Yep. All right, so there's my equation. So now the question says, how long will it take for the 10 grams to decay to only 1 gram? So now I want to know what is the time going to be till I only have 1 gram left. So 1 gram. So I am solving this equation. Okay. All right, so I'm just wanting to know how long, find t for when I have my y value is 1 gram. So we divide by 10, that's going to be 0.1 e to the negative 0.0002845 t. I'm going to do the ln on both sides. I'll squeeze it in there. Natural log. So this will be the natural log of 0.1 equals, we multiplied this exponent to the front. And of course, when you do that, the ln of e is out here. You just multiply this exponent to the front times ln e. We know ln e, though, is 1, so that's really unnecessary to do. So t is going to equal the natural log of 0.1 divided by this nice little decimal, 0.00002845. So let's see how long that is. Let's see. The natural log of 0.1 divided by negative 0.00002845. Woo, long time. So that's going to be 80,934.450, rounded to 3 decimal places. And that was in years. Woo, long time. So 80,934.45 years, that's how long it'll take till we have 1 gram left, because the half-life occurs every 24,000. All right, so that makes sense. All right, if you're thinking half-life, you had 5, then you have 2.5, and then you'd have 1.25, and then you'd have 0.625. So you have to go at least 3 times, and 3 times this is in the 70s. 3 times that's like 72. You got to go a little bit further than that. So then, yep, 80,000. All right, so that was a radioactive decay one. Notice, because it was decay, our K value ended up being a negative number because this was a half-life, so we had radioactive decay. So notice that our constant of proportionality ended up being a negative number. All right, number 8, suppose an experimental population of fruit flies increases according to the law of exponential growth, which is this equation. All right, there are 100 flies after the second day. So after 2 days, we have 100 flies. And there are 300 flies after the 4th day. So after the 4th day, there are 300 flies. So I'm just taking the word problem and translating it. So after 2 days, I had 100. After 4 days, I had 300. So approximately how many flies were there in the original population to start with? So my question is, how much was there at time 0? That's the question. So I'm just going to take these 2 values and solve. So we're looking for our initial population C. Okay, so let's just plug these numbers in there. So I have 100 when T is 2. I have 300 when T is 4. So all I did was plug in, this is T, this is Y, this is T, this is Y. So when time is 2, I have 100 flies, and when time is 4, I have 300 flies. So now I've got to use these 2 equations to solve for C. All right, so here's how I'm going to do this. If you notice, if I multiply this top equation by 3, I'll get 300 equals 3ce to the k times 2. And so then I can set these 2 guys equal. So then ce to the k times 4 is going to equal 3ce to the k times 2. All right. Now, you'll notice your c's cancel, and that's what we're trying to find, but, you know, eventually we're going to come back and find those. All right, so I'm going to divide e to the k times 2 on both sides. Okay, so that'll give us 3 equals. Now, what do you do when you divide powers? You subtract your exponents. So k times 4 minus k times 2 is going to give me 2k's. So now I do the natural log on both sides. So it's going to be the natural log of e to the 2k equals natural log of 3. So we multiply the 2k to the front. All right, we know that natural log of e is 1, so he goes away. So 2k is going to equal natural log of 3, and then we divide by 2. So our k value is the natural log of 3 divided by 2. Okay, so that's our K value. So now using that, I can go up here and I can substitute into any one of these equations and it'll help me figure out what the initial amount was. So if I just use this initial equation right here, 100 equals C e to the K. What did we just find K to be? Natural log of 3 over 2. So natural log of 3 over 2 times by 2 because that's my time. All right, so I'm just plugging in here the K value in there in one of my equations. I could have done this other one too and it would have been the same thing. So now I'm going to solve for C in this problem. So this will be 100 equals C. These 2's cancel. What's e to the natural log of 3? Well, e and natural log of 3 cancel, so that's 3. And then I'm going to divide by 3 on both sides. So 100 divided by 3 is 33.333, right? So that's how many flies there were at the beginning. So approximately 33 and a third. So approximately 33. So 33.333. Don't know how you can have a third of a firefly. All right. Somebody was getting ready to have little flies. All right. So your initial population was about 33 fireflies. Okay. So that's how you do that one. You were given 2 ordered pairs. You just substitute both of them in. That gives you a system. You solve your system. The C's ended up canceling away. But still, you find your K value. And you plug your K value back into one of the 2 equations you were given. And that will calculate your C constant. So you could keep it 100 thirds. Or you can reduce it to 33.333. So both of these answers will be right. 100 over 3 or 33.333. Okay, is how many we had in the original population of the flies. All righty. So this one, it says 4 months after it stopped advertising, a manufacturing company noticed that its sales have dropped from 100,000 units per month to 80,000 units per month. So if the sales follow an exponential pattern of decline, okay, which is this same equation, y equals C e to the kt, it's just we're doing decline, so that means we're decaying, so our K is going to be a negative number. What will they be after another 2 months? Okay, so it says 4 months after it stops advertising, a manufacturing company noticed its sales have dropped from 100,000, so that means at time 0, we had 100,000, and then 4 months later, it dropped from 100,000 to 80,000. All right, so at time 0, its sales were 100,000, and then 4 months after it stopped advertising, we're down to 80,000. Okay, so this is what we're going to use into our equation. Well, we know this part times 0. This is our C, right? So y is going to equal 100,000 e to the kt. All right, so we got that one. So now we use the second ordered pair to find our K value. So 80,000 is going to equal 100,000 e to the k times 4. And then we're solving this equation. So when we divide here, 80,000 divided by, I'm pretty sure that's 0.8, because once you get rid of your zeros, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, it's just 8 divided by 10, so that's 0.8, 8/10 e to the 4k. And so now I'm solving this by doing the natural log on both sides. Do the natural log on both sides, so that brings the 4k to the front here. So 4k ln e, and we know that ln e is 1, so that goes away. And that's natural log of 0.8. And then we're going to divide by 4. So k is the natural log of 0.8 divided by 4. And the natural log of 0.8 is a negative number. Let me pause this here. All right, so now let's see. So yeah, the natural log of 0.8 is a negative number, and then when you divide by 4. So this is a negative value, which we know it should be because it says it was on a decline, exponential pattern of decline. All right, so my equation then is y equals 100,000 e to the k. K is this number here, natural log of 0.8 divided by 4t. So there's my equation. So now, what will it be after another 2 months? Okay, so another 2 months is going to be at 6, right? So we're at 4 months later, so for another 2 months. Okay, so this is my equation now. When I put my k value in, the natural log of 0.8 divided by 4 in place of my constant. So now the question is, what will it be after another 2 months? So 2 months further down the line, we'll be at 6 months after we stop the advertising. The advertising, yeah. So I'm going to put a 6 in for t. Okay? So y equals 100,000 e to the natural log 0.8 divided by 4 times by 6. Because we want to know now, after 6 months, what will happen. And so then you're just typing that in your calculator. So 100,000 and then e raised to the... All right, so when I just type that in my calculator and I press enter, I'm getting 71,554.175. So we were down to 80,000. So now after another 2 more months, we're going to be down to 71,554 units per month, because we're on a decline in productivity, units per month. So that would be your answer. All right, so that was the last one. So your assignment's on page 366, these problems here that you will submit into Canvas. So good luck.